welcome back to my channel Bal Vigyan Varti. Today, before starting with a new problem in arithmetic progression, let me take you to the part where 2 episodes back we have not discussed further, as that was a part which is needs some tips and you can say some way, a different way of solving that part. And that example what we have taken is that example where we are discussing that in case any standard series, wherever it is required to be used directly, you can use it. You need not to calculate it then and there. The example that we have taken is this one, when the series is such that it is not giving a idea of direct AP series. Rather, if I manipulate it a bit, that means if I take the difference of the consecutive terms, that itself is giving a AP series. So while we are solving that, we have come to a point where we need to get a sum of a series which is the squares of all the natural terms being added. So this is not yet we have come across, so we have parked this there, saying that it needs some different idea and tips to solve it. So as my intention is to not to confuse the viewers with so many of criticality, rather if we go from simpler to the tougher, that will be much acceptable to the viewers or the students. So we park this there, we not discussed, but we should not be drag it too long, so that people will be lost the energy or the interest into it. So I will discuss it today before going to the next problem. And the series was the square of the natural number sum. So this is not only the square, this could be of any power that they are told, and there is a generic way of solving that. And if you can understand one way, you can solve the case where the powers will be more, okay, for those natural numbers. Okay, so let me write the series first. What we have to find? You have to find the sum of the series which carrying 1 square, 2 square, 3 square plus dot 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 up to n square. N could be the number of terms, n could be anything if it is finite. Okay, so we are talking about the finite series where the terms are like that, the squares of all the natural terms, consecutive natural terms. So okay, so for that, the tips is that you have to start from the step where I will take the difference of these two terms with a power higher than the power existing here in the series to be summed up. So that means if it is square here, I will start with a 1 power higher, that is cube. So on the terms would be r cube minus r minus 1 cube. So r could be any value which represents the position of the terms in the given series. So that means r can be 1, 2, 3, 4 up to n, any value. So we can write r belongs to natural number here, because we are talking about the natural numbers. Okay, and this specific case will applied only for the natural numbers where the power could be anything, any finite term. So okay, so I'm starting with the terms r cube minus r minus 1 cube. What I will do, I will expand the things on the right hand side. Let me see what I am getting here. So r cube minus 3r square plus 3r minus 1. So if I remove the bracket, I will get r cube minus r cube plus, now accordingly the sign will change, r square minus 3r plus 1. Okay, so this will be the case. Now you can see on the right hand side, r cube will be cancelled out and I will leave the terms as it is. Rather, I will write the thing in the form of this. What I am writing, 3 into r square minus 3 into r plus 1 to distinguish the coefficient from the variable. What I will do next, I will put the r value starting from 1 consecutively up to n in each term. So first if I put r is equal to 1, so my term will come like that, r 1 cube minus 0 cube is equal to, and I will not calculate the term here, rather I will put the thing as it is, 1 square minus 3 into 1 plus 1. Okay, the next term will be r, putting r is equal to 2, I will get 2 cube minus 1 cube. Now you can see things are going in a rational way, and this is giving some hint how the series will move along. So now if I put similar things, all the similar way, if I put the value till n, the last term will be, when you will put r is equal to n, so it will be n cube minus n minus 1 whole cube is equal to 3 into n square minus 3 into n plus 1. Now if I sum up all the columns, not cumulatively, I will add up all the columns. So now on the left hand side, what you see, all consecutive terms on the next term, all means alternate terms, means first term of the first and the next term of the next will cancel each other. So if I do like that, all the terms intermittently will be cancelled out. Only the terms which will remain is n cube here, and as 0 doesn't have any meaning, I will not going to write it. So 0 means 0. So n cube minus 0 will give you the n cube itself. So what I am getting here, if I sum up column wise, so I can take 3 as common, and that remaining things will go inside a bracket, and it will be something look like this. Okay, the series that I am going to get the sum. So I will put it like that. The next will be the similar way. I will get 1 plus 2 plus dot 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 till n, and the last terms all adding up 1. How many 1 will be there? N. So I will get definitely n. Okay, now put the things like that, because this is represented by s. I will put for simplification s. What is this? 3 into all the numbers in natural way with the power of 1. So natural numbers sum. So this we know directly, we can put the value of the sum of the natural numbers is this and plus n. So now what is your unknown? Unknown is this one. All the terms is having n as a value, because this is a combination of n. So these are all known, you can say, because n is known to you. So I can put all the variable one side, all the the known one side. So keeping 3s on the left side, other things if we go, the sign will change, because these are moving on the side of n cube. So this definitely will change its sign accordingly. Now what I have to do, I have to calculate all this. So you can see only in the denominator there is 2, so 2 can be taken as a LCM for that, and for that the thing will change like 2n cube plus 3 into n square plus 3 into n minus 2n. So ultimately 2n cube plus 3n square plus n by 2. So this is equal to 3s. So my result will be, when I will get s, so s 3 will be will come this side, so this will give you 1 by 6, and inside bracket 2n cube plus 3n square plus n. So you can simplify this by taking n as a common factor of this all, 2n square plus 3n plus 1. Okay, so now further you can also improvise it by factorizing. If I factorize it, I will definitely get, you can practice at home, you will get this as a result, 2n plus 1 n plus 1. So keeping the things accordingly, I will get, because I am just moving with a higher order letter, so 2n plus 1 will be the higher value than n plus 1, so I am keeping n plus 1, 2n plus 1. So this will be the result for this series when I am calculating the sum of n square, 2 square, 3 square, n square. Now I will give you one more example where I will go for higher order. Now why I am doing this first with the lower order, you can understand, because you may need the sum of this when I going for the higher order summation. So let me take you to the problem directly so that you can understand it better. So now my sum will be, I want to get the sum of 1 cube plus 2 cube plus 3 cube plus dot till n cube. So now I have increased one order high. So with the set rule, what I have to do, I have to go for one more higher. In place of earlier r cube, I will take r to the power 4, and the remaining thing will follow the same way, r to the power 4. And now if I expand it, I will get r to the power 4 minus, you know how to expand a binomial series. So this is r to the power 4 minus 4 r cube plus, alternatively, because this is minus, so alternatively it will get plus minus plus, this will give 6 r square minus 4 r plus 1. As because this has power is 4, so number of terms will be 5. That we have already come across when we are discussing about the binomial series, isn't it? Okay, so further I will remove the bracket, and as we did earlier also, we will do the same thing. We will simplify this part, then after we will put the value of r consecutively from 1 to n. So here you can see, by simplifying, the ultimate relation that I will get, r to the power 4 minus r minus 1 whole to the power 4 is equal to 4r cube minus 6r square plus 4r minus 1. Now without putting r is equal to 1, if, as you know, r belongs to integer and r could be 1 to n. So if I want to put r value consecutively, I will get the same series, whereas knowing r is equal to an integer, if I sum up all the case, means this side is a different case. If I sum up taking r is equal to 1 to n, this is also a way of representing the thing, summation of r is equal to 1 to n for this case. Okay, so now when I put there, I will lose my alternate terms, and ultimately this side, you know what you will get, I will get n to the power 4 as a result, whereas this side individually I can put it like that, r is equal to 1 to n. And so you can follow the earlier process, or if you are if you are advanced to your in your mathematics, so you can also represent the things like that to reduce the time and energy. So this is also one kind of representation where the things will say you the same thing. So putting r consecutively 1, 2, 3, 4, 5, 6 n, or putting a symbolic that you are going to add up this individual terms when you are getting taking the value of r is equal to 1 to n. This is also a symbolic where constant can be taken out, only variable part will represent similar way. So all the terms can be represented in this manner, okay, to get the sum. So this is 4 into summation of r is equal to 1 to n r, and minus what we will say here, r is equal to summation of r is equal to 1 to n when you are summing up one constant. So you will get all this number of n. So putting this, so what I am to get, this is as a sum, so I will put this as S1, because this is nothing but the same thing. Putting r value is 1 to n and putting it in a symbolic way, that r is equal to 1 to n r cube, will give you the same presentation. So for r1, and this, now you see, unless I had did the earlier step, I could not have got the value of r square. R square means 1 square 2 plus 2 square plus 3 square, like that. So this series I only could have, this sum only could have when you have finished the earlier one, if you know the value of this. So this is my intention of telling you that once you want to go to the higher series, all the lower series sum has to be handy to you, okay, before going to the higher order. So this we have taken already, n into n plus 1, 2n plus 1, just now we have derived, plus this is a natural sum of the series 4 into n plus 1 by 2, and this will give you n. Now you can simplify all this by taking the variable one side and the unknown one side. Okay, what you can do, you can simplify this, 6 will cancel, 2 will cancel, so this will give you n into n plus 1, 2n plus 1 plus 2 into n plus 1 minus n. Now you can simplify n to the power 4 minus, if I multiply it will be 2n square plus 3n plus 1, so 2n cube minus 3n square minus n will be the case. Now here plus 2n square plus 2n minus 2n minus n. Now according to the order you can simplify the terms. N cube there is only one, so you can put as it is. N square there is one term, here one term, so ultimately it will be n square. N is minus n plus 2n, so all will be nullified. So what you can take common from this will be n square, you can take out, so this will be n square minus 2n minus 1. Okay, so this will 2n square, this is n square minus 4n, so this will go on that side, so I have made a mistake. This will be minus, this will be because that was there on the s side. When you will go on the n4 side, it will be get plus sign, it will be minus, this will be plus. So I have made a mistake, this will be plus and this will be my plus, and this will be minus. So I made a mistake in the signature. So this is n to the power 4 plus 2 n cube, and n square is equal to plus n square, and n into n is equal to 0. So now this will be n square, if we take common it will be n square plus 2n plus 1. So ultimately this will give you n square into n plus 1 whole square. So that means n into n plus 1 whole square. So S1 you can say it is 4 can go inside, so ultimately this is n into n plus 1 by 2 whole square. Now you can see the similarity, this is the sum of the natural series, so this can also be can be put in one corollary, that means in a property where sum of the cube is the square of the, this also can be needed to be proved somewhere, that sum of the cube of the natural series is the square of the natural series. That means it is giving you the sum of all natural series taking r is equal to 1 to n, that's whole square. This also can be proved, but you can use it as a direct formula for higher order. That is my intention to prove. Okay, so I will stop it here because this is a very lengthy. You can go through this and try to understand it better, and moreover you can try one more step higher than this and see whether you can able to do it or not. Okay, so I think I have explained enough, and you can do it very easily. So thank you for now.